Hi there, welcome back to my channel. Today I am back with another tutorial for you guys. This time I will show you some advanced soft body simulations. Soft body is very great for adding jiggle and wiggles to your meshes. So in this tutorial, I will show you some examples which you can do with soft body simulations. You will learn how you can add more life to your keyframe animations by just adding soft body simulation. So let's get started.
This video is sponsored by 3D Export. Buy and sell 3D models marketplace.
First of all, we will learn some basics. For the basics, we have the monkey head and a subdivided plane. First select your base and add a collision property. And then select your object and add the soft body. Now I will show those settings which we are going to use in this tutorial. First, we have object. This is an overall setting for the object which have the soft body. Under object we have friction. Friction of the surrounding medium which is used in collision with the plane. Mass. Mass is the weight of our object. Heavy object have slow simulation movements and light object have fast movements. Then we have control points. This allow us to use the vertex group to determine the weight on each vertices of our mesh. Like as you can see, we can add a vertex group and assign different weight to different vertices or polygons. Then next we have simulate. Under it we have speed, which is self-explanatory, it is the speed of the animation of the simulation. Then we have cache, it can bake your animation in the given frames. Here's we have goal, which is one of the main settings of the soft body. I will explain this goal setting. Goal is the property which tells Blender to use the external motion from the animations given to the object. External motions such as keyframe animations, armature bones animation, or if you parent the object with another object and give some animations on the second object. Example, I am giving location keyframes to the object, one here, and another one here. If I disable the soft body, you can see the animation. And now I am re-enabling the soft body, with goal checked. You can see the simulation have our keyframe animation as well. As you can see, it is blending our keyframe animation with the simulation. To determine the blend intensity of simulation and your animation, this option default will help you. This default value is like a transition between the simulation and the animation. It is set to 0.7, which means 70% of animation and 30% of the simulation. If you set it to 0, it will fully goes to the simulation. And value of 1 will remove the simulation completely. Under the goal we have vertex group. We can assign vertex groups for the goal. Create a new vertex group, select these vertex and assign weight to 1. I am repositioning the head to see the effect. And set the vertex group. Play the animation. You can see it is slightly pinning the vertex group. The intensity is low because the default value is 0.7, change it to 1. And now you can see it is pinning perfectly. Here, you have the minimum and maximum for the default value. If you had set the default to 1, then there is no point for minimum. You can understand better in weight paint mode. As you can see here, the red area is maximum and the blue is minimum. And if you will set the default to 0.7, then we will able to set some minimum value, like 0.5, so these blue area will have the 0.5 value. Which means the area which is in blue, now also have the weight of 0.5 minimum. You can see the main vertices are pinned, and the other vertices have also some amount of weight as well. Set the default back to 1, because we need it in further explanation. Then we have edge, which is the main settings for the soft body. If we uncheck the goal, then our object will no longer see any animation which we had given. I am re-enabling the goal because I need it. First we have spring. Spring is nothing but a motion between the edges which occurs because of simulation. Spring vertices, it will use a specified vertex group for spring strength values. Next we have push and pull. The basic difference in push and pull is the stretchiness of the body and push is the flexibility of the body. The pull setting will determine the stretching of the edges. The lower values will make more elastic and the higher values will make the body less elastic or stiff. The The push is the flexibility of the body. Lower values make the body more flexible, or I can say it will have less air inside the medium, and higher values make it less flexible and give more air inside the medium. Here is an example of both pull and push is in low value. The body becomes very flexible and elastic. The damping setting will smoothing the push and pull effect in the simulation. The plasticity will use to deform your soft body shape in the simulation. Lower values will less deform the shape and higher values will more deform the shape. Next we have bending. It is used to preserve the actual shape of the object throughout the simulation. Higher values will preserve the initial shape, and lower values will deform it. Next we have length. It can inflate or deflate the body. 0 means the option is disabled. If you set it to 100, that means size is 100%, which is same as we have already. If you set it to 50, it will become half the size of it. And 200 will boost the size to 200%. Now we have self-collision. It is same as in cloth simulation. It will enable the soft body to collide with itself and prevent from intersecting. Now I will move to our first example here. These two models I will use for the simulation. Let me show you that I am using very low poly models for the simulation. Because soft body is very slow in terms of high poly calculation. Let's position the objects to fall. Duplicating it and placing here and there. Now I am adding a plane for collision. Let's add one more object for obstacle, and see what happen if it collide to it. I am quickly modeling a bowl type shape. Make sure you had given some thickness to the obstacle for better collision. Apply scale on both obstacle and the objects. Joint the objects, which will be our soft body simulation. Now add the collision to the bowl and the plane. And add the soft body to the objects. I am unchecking the goal here. Bump up the pull and push values to 0.8, as we don't need much flexibility and stretchiness, and raise the damping value to 20. Set bending to 6 and plasticity to 5. Enable self-collision, and boost the ball size value here. This will act as it is adding some air in these bodies. And now bake the simulation. Now my baking is finished. It looks like this. Now let's move to our another example here. This fish model is from turbosquid.com, link in the description. I had given noise modifier on the rotation keyframe of this model, so that it can move like it's swimming. Now what I am going to do is, I will animate her fins with soft body. So first of all create a vertex group here. Give a name, I am calling it weight. Now, in edit mode, select the polygons of the fins. And tail also. Unhide these, and hit Ctrl+I to invert the selection. And assign the weight to 1. Now go to the weight paint mode. And smooth this with the blur brush. Now, I have added the soft body. Under Goals, select your vertex group. Leave the settings and go to the strength and increase the default up to 1. Now play the animation. Okay, we got the soft body that we need, but we have to adjust the settings. Disable the gravity. Now come to the edge part. Set the damping value to 2 and bending to 10. Check the self-collision and give the ball size to 0.5. You can see we got our soft body, but it doesn't react naturally. For this I have to add some force field to mimic the underwater medium. I am adding wind, to act as water flow. Positioning it. Rotate it, to face the fish. Crank up the strength to 10. Let's test it. We got some movement in the fins. Select the fish and go to the soft body and crank the damping up to 50. Now we got some waving of the fins. Let's bake it and see the result. I know that a real fish doesn't move like this, but my point was to show how we can add some soft body movements with a keyframe animation. Now we will go to our third example here. We will learn to how we can add a secondary animation to our rigged model like this. We will learn the jiggle animation, on which I was working from a long time. Meet Elly. Her trunk is a soft body which jiggles with her body movements. The technique which I will going to show, you can also use that in muscle animations, body jiggles, breast jiggles, etc. Here is my base model. I have an animation also on this model. This animation is from Mixamo. To make her trunk jiggle we have to model a muscle mesh, which we will later bind to our high poly mesh. So I am adding a cube here. Adding a subdivision. Modeling the trunk. Make sure your shape is similar to the original one. All the polygons are inside the original one. So this is our muscle mesh for our trunk. We will add soft body on this mesh. I am adjusting the vertices, so that it will not give any problems in the stage of binding. Make sure every vertices is inside the original mesh as possible. You can see our trunk stays there, and the model is animating. We have to parent the model to the armature. To do this, hide your original mesh. And see the bone which is responsible for the movement of the jiggle body part. In my case it is the head bone. So select your mesh, then select your armature, and go to the pose mode, and select the head bone and set parent to bone. This will allow the trunk muscle to follow the movement of the original trunk. I am moving the muscle mesh to its own collection called muscles. Now we have to create a vertex group, on which our trunk will hang or wiggle. Select your trunk mesh and create a vertex group, called weights. Go to the edit mode. Select these top polygons, and assign the weight to 1. This is how it is looking in the weight paint mode. Remember the red area will not have soft body, it will have the external motion of the bone, which I had talked about earlier in the goal section. So the red area will able to move with the bones and the blue area will jiggle naturally. Now it's time to add the soft body. Under the goal select the vertex group. It looks like this for now. You can see the soft body is following the motion because of the vertex group we added. Leave the settings and go to the strength and increase the default up to 1. Now come under the edge. We don't need much elasticity, so we will give the pull value to 0.5, and we want a good amount of flexibility or jiggle, so we will give the push value to 0.1. Give a huge amount of dampening, as we does not want any jitter in the movement. And set the bending to 10. This is it for the edge. Enable to self-collision and give the ball size to 1 and stiffness to 5. Now play the animation. You can see we are getting our jiggle movement. You can see different results in different self-collision settings. If you want a very flexible and elastic trunk, you can decrease the push and pull values. Now we have to bind the muscle to the original mesh, so that our original model have these jiggle animation. First of all, I am giving some materials to the model and the muscle mesh to differentiate between them. Now select your model and add a surface deform modifier. Set the target to your muscle mesh. We need the binding effect, only of the trunk part, so we need a vertex group for this. I am creating a vertex group called trunk on our original mesh. Select the trunk in the edit mode and assign the weight to 1. Go to the weight paint mode and blur the selection to add some smoothness. Now back to the surface deform modifier, select the vertex group here. And hit bind.
NANI?!
Nothing is easy in life. It will always pisses you. To fix this, place the surface deform modifier above the armature. And voila, it's fixed. Short note here, always remember to bake your soft body. So this is it for the trunk jiggle animation. I will also show you how I made her floppy ears. For ears, I had used cloth simulation. For this, you have to make a ear muscle mesh also. So duplicate the mesh, move it to the muscle collection, and add the muscle material. Now select the head and the ears in the edit mode. And yes, delete the surface deform modifier. Now I am selecting the head only with ears. Keep the head with ears and delete everything else. I am keeping the head part, so that the ears will also collide with the head when I add the cloth. On this mesh, add a vertex group, called ears, and select the vertex of the head only. This will be going to use for pinning the cloth. In weight paint mode you can see the selection. As this is very high poly for cloth calculations, I am adding a decimate modifier to lower the poly count. Set it to unsubdivide, and give 1 iterations and apply. Yeah. Delete shape keys if you have any. The UVs have changed. Make sure the vertex group is still same. Yes, it is. Smoothing it with blur brush. Now add the cloth. Add the vertex group under the pin section. This is my cloth settings. Bake the animation. Oh yes, floppy ears. I like it. You can see, this is why we included the head part also in the ear muscle mesh. The ears are colliding with the head. With the same technique we will bind the ears with the original model. Use the surface deform modifier, but first select the mesh, add a vertex group called ears, select the ears and assign weight to 1. Smoothing the vertex group in weight paint mode. And now add the surface deform modifier, select the ear mesh as target, set your ear vertex group, place your surface deform modifier over the armature, and hit bind. Please note, don't place your cloth simulated mesh surface modifier over the armature. Reason? I hell don't know. So to make your life easy, place the soft body simulated mesh over the armature and cloth simulated mesh under the armature. And if you done it all right, you will see something like this. If you are curious for my final result, I added eyes, hair, a bow and a skirt to our Elly. I had given a cloth simulation to the skirt as well, because obviously skirt is a cloth. For the hairs, I have given hair dynamics to it. Maybe I will make a video on this topic. If you want that to happen, you have to do these steps. Like the video, share it, subscribe the channel and ring this bell. And I will see you in the next one.